Hello guys and welcome back to another tech video from Design Fusion. My name is Gaurav and today I'm going to show you how to perform a linear static study on Surface in SolidEdge Edge 2023. Before we proceed to a step-to-step instructional video, I want to explain what linear static study is in SolidEdge. Edge. A linear static study is a type of FEA that is used to analyze the structural behavior of a model under the effect of loads and constraints. It is based on a principle of linear elasticity, which means that the material behavior is assumed to be linear and the loads and displacements are assumed to be small. Let's begin. Here is an assembly consisting of sheet metal parts, square tubings, and steel cylinders. Now let's prepare the geometry. I'm going to create three mid surfaces on the back of this panel. The first mid surfaces would have a ratio of 0.50 and the other two tabs would have a ratio of 0. I'll make sure that I would offset it from side 1 like this. Now I'm going to create a copy of all the faces left. So this is to be done in order to create my design body into surface body, and I'll show you once I create those. Another way to see if your design body has been created to a surface body is to go to Simulation tab, and under the geometry you can see. I'm going to hide all my design bodies so just I can see that I've created all my surface body in a right way. Now the next step is to create a study. This study will be on linear static and the mesh would be on the surfaces. I will define all my surface body. As soon as I hit accept, you can see on the left hand side at the Pathfinder all my surface body have been transferred to my study as well. Now I can edit the thickness of my copied faces just by clicking on edit thickness. Here I will put 3.23 and on the square tubing I will put 4.23. The thickness of this has been already inspected by an inspect tool in itself in SolidEdge. Edge. I will change and edit the thickness of all copied face to their original thickness just to make my surface body more realistic. Once the thickness been defined, I'm gonna go ahead and create a load. In this load I will use the force. Force will be acting on our steel cylinders. Direction of my force would be downwards and the value would be 250 pound. Once our load's been defined, I'm gonna go ahead and create a fixed constraint. I'm gonna select two faces as you can see on the left and right hand side and give it a fixed constraint. Now it's time to create connectors. I'm gonna use a very beneficial command in SolidEdge. Edge. It is called auto connectors. What it will do is it will identify the face-to-face connectors and will automatically put connectors to it. Now you can see in the result two copy faces have been popped up. As soon as I click on create connectors, it will automatically put faces and surfaces connectors to it. Another thing to notice is in a correct defined assembly connector, the face and surfaces in the target region and the face and surfaces in the source region should point towards each other, which means cone must be pointed in the same direction. But this is not the case here. However, I can always select edit region direction and can flip the direction. But I will not do so because I'm not getting any errors in my results. Now that our faces and surfaces connectors been done, we're going to go ahead and create edge and surface connectors. I'm selecting all the edges associated. Now I will select the surface related to my edges. I will repeat the same scenario on the other hand as well. I will first select all the edges, and then the surface. Now that everything's been done, let's go ahead and do the post processing, which means let's create mesh on the surfaces and solve our study. I'm gonna go for a good 7. Here you can see the deformation. The yield stress is 38, but our maximum deformation is around 7, so it means our model is safe and ready to use. And in the next video, I will go through how we can create unite bodies and how it will save the time of the user while doing pre-processing. So stay tuned.